Hello friends, welcome to you in my lecture classes. Today we are going to solve a combined problem on displacement and velocity analysis. And this is a problem from GATE 2007 and regarding a quick return mechanism. So let me give the statement of the problem. This is a quick return mechanism OPSQR. So OP is the fixed link and length of the fixed link is 500 millimeter. PQ is the oscillating link, OS is the crank, and R this is the point of center of revolute pair here, that is R, and this is the slider which is sliding. And it is given that quick return ratio of this quick return mechanism is 2:1. So quick return ratio is 2:1. So first question is determine the length of the crank, that is OS, in millimeter. So determine the length of the crank, whereas the length of the fixed link is 500 millimeter. This is in millimeter. So we have to find out the length of the crank. So this is in 500 millimeter. Quick return ratio is 2:1. So let me draw the mechanism here also. This is point P and this is point O. So let me first locate the extreme right position and extreme left position of point R to determine the quick return ratio, and from that relationship we will determine the length of OS. So point S is on crank. Point S is on crank also. Let me denote the fixed link by 1 and crank by 2. So point S, when the crank will rotate, say the crank is rotating in counterclockwise direction. So the point S will generate a circle of radius OS. So point S will generate a circle of radius OS and center at O. So from center at O, we will draw a circle of radius OS. So this is the circle generated by point S. Now at extreme position of R can be determined by drawing a tangent to the circle from point P. So when the block, that is the sliding block or tool holder, this is the tool holder, tool is fixed here. So this block is nothing but the tool holder. So when the tool holder is at extreme right position, the oscillating link will make a tangent to this circle. So we will draw a tangent to the circle from point P, and this is point Q R. Suffix R represents the extreme right position, and the corresponding position of the crank will be here, and this is SR. So these are suffix R is represents that this is the extreme right position. Now from QR, and we will also draw the axis of the slider. This straight line, horizontal line, represents the axis of the slider. Let me draw it somewhere below. So right now from QR we will draw an arc of radius this much, that is QR, at center this revolute pair, and that will cut the axis of the slider, say at this point. So this is corresponding point is RR. So this is the location of extreme right position of the slider or tool holder. So this is the tool holder, this slider is tool holder. So this represents the extreme right position of the tool holder. What we have done, from point QR, we have drawn an arc with radius of this link length QR, and that cuts the axis at point RR. So this is the corresponding position of extreme right position of the tool holder or this slider. Now let me denote the link numbers. Fixed link is 1, crank is by 2, this slider is by 3, oscillating link by 4, this by 5, this link by 5, and this is by 6. So there are 6 links. Now you can easily locate the extreme left position of this slider or tool holder by the same process. We will draw a tangent to this circle from point P. So this is your SL, this is point SL. L suffix L represents extreme left position. This is QL, and from here we will draw another arc of link number 5, say which intersects the axis of the slider here, and this point is RL. So this is RL. So stroke of the mechanism is this much. So this is the stroke of the mechanism. Now if we consider, let us consider that the crank is rotating with counterclockwise direction with uniform speed, then say we have started from this instant, that is from extreme right position, and crank has started rotating. So the corresponding position of the tool holder is at here. This is the tool. So here, and when crank reaches from OSR to OSL, then the tool holder reaches from RR to RL. That is, it has completed the forward stroke. So from forward stroke, this is forward. So from forward stroke, the tool holder moves from RR to RL in left hand direction, from RR to RL, and the corresponding rotation by the crank is denoted by theta F. So theta F is the rotational movement of the crank during forward stroke. Similarly, from OSL, crank moves from OSL to OSR, and this is the angle travelled by the crank during return motion, and the corresponding motion of the tool holder is from RL to RR. So this is my return. Now look at here carefully, that is theta F is greater than theta R. So the time, and crank is rotating with an uniform speed. So the time taken during forward stroke is more than the return stroke. So there will be a quick return ratio. So quick return ratio, I am explaining you first quick return ratio, that is time during forward stroke, quick return ratio is time during forward stroke by time during return stroke. And that is what is the time during forward stroke? If angle traveled by the crank is theta f, then theta f by omega. Omega is rotational speed or angular speed of the crank. That is, the crank is rotating with a uniform speed. So omega is a constant. So theta r by omega. So that is theta f by theta r. Now in the problem it is given that theta f by theta r is 2 because quick return ratio is 2:1 and theta f plus theta r is 360 degree. So solving these two, you can determine that theta r is 120 degree and theta f is 240 degree. So solving these two equation, this ratio is 2 and summation is 360 degree. You can easily find this. Now if this is a tangent, PQR is tangent with this circle, then this angle is 90 degree. This angle is 90 degree. So if this is 90 degree and this angle POSR, this angle POSR, that is theta r by 2 because total is theta r. So this much will be theta r by 2, angle POSR. So cos of angle POSR is how much? Cos of angle POSR is OSR by PO. OSR by PO, cos of this angle, that is POSR. And theta r is 120 degree, so this is 60 degree. So cos of 60 degree is OSR divided by PO is given, that is 500, and cos of 60 is half. So OSR becomes 250 millimeter. OSR is nothing but the link length OS. This R represents the extreme rightmost position, that's why I have used this suffix SR. So this is the problem. So when quick return ratio is 2, that is theta r is 120 and theta f is 240. So if quick return ratio is 2, that is theta r by 2 is 60 degree and cos of 60 is always half. So when quick return ratio is half, then length of the crank, when quick return ratio is 2, then length of the crank will be half of length of the fixed link. So this is the fixed link OP and this is the crank. If quick return ratio half, then this angle, that is theta r by 2, this angle becomes 60 degree and cos of 60 is half. So when quick return ratio is 2, the ratio of crank by fixed link will be half, and that is 250 millimeter. So Option A is correct. So this is the correct option, and we have determined the length OS. Now the next problem is very conceptual problem. That is, it has been asked. Before that, let me erase this, because we have done already so many things here. So for your better understanding, I want a clear page. So next problem is that you have to determine the angular speed of PQ, that is the oscillating link. Angular speed of PQ, omega PQ, when this block, that is point R lies on this block. So this block or point R achieves its maximum speed. So when point R attains its maximum speed, at that instant, what is the angular speed of PQ? And it has been given during the forward stroke, and we have already seen that forward stroke is from right to left. So during forward stroke, when this block attains maximum speed, then what is the angular speed of PQ? So let me draw same thing. Let me draw the instants. This is the circle generated by point S. Now, when the slider is at extreme right position, so this is RR, this is QR, this is point P, and this is O, this is SR. Or let me denote this by only S for your understanding. Now let me check at this instant when the block is at extreme right position, or the tool holder is at extreme right position, what is the velocity of this block? And let me denote the link numbers also. So fixed link is by 1, this is by 2, this is by 3, this is by 4, oscillating link, this is by 5, and this is 6. Now in the last lecture we have solved a problem, that is the point S. This is the point S which lies on 3 links. Point S lies on link number 2, it lies on link number 3, that is the slider, as well as it lies on link number 4. So there exist 3 instantaneously coincident points, S2, S3, S4. S2 is point S on link number 2, S3 is point S which lies on link number 3, and S4 is point S which lies on link number 4. And out of these 3, S2 and S3 remains always coincidence, because if S is the center of the revolute point joint, then it connects link 2 and 3. So S2 and S3 moves together. So velocity S2 is velocity S3, as they always remains coincidence, and these things I have discussed in my previous lecture. But S4 is instantaneously coincidence. As the crank rotates, then S4 shifts from S2 and S3. As S2 and S3 always remains coincidence, that's why Vs2 is equal with Vs3. Vs2 is what? velocity of link 2 at point S. Vs2 is velocity of link 2 at point S. Vs3 is velocity of link 3 at point S. Okay. So now we will apply the concept of relative velocity between two links, that is link number 3 and link number 4 at point S. So what is the equation? Vs3 is equal with Vs4 plus Vs3 by 4. Let me define the terms. Vs3 is velocity of link 3 at point S. Vs4 velocity of link 4 at point S. And Vs3 by 4 is what? Relative velocity of link 3, relative velocity of link 3 with respect to link 4 at point S. And what is that? The relative velocity of link 3 with respect to link 4 is nothing but the sliding velocity, because link 3 is restricted to slide only along link 4. So that Vs3 by 4 is always along this link, that is link number 4, that is PQ. So this is always along PQ. What is Vs3? Vs3 is nothing but Vs2 also, because S2 and S3 always remains coincidence. We have already noted that Vs2 is Vs3. So Vs4 plus Vs3 by 4. Now what is Vs2? Vs2 is, if this is omega 2 into OS2. Okay, omega 2 into OS2. And what is the direction? That direction is perpendicular to OS2, perpendicular to OS2. So at this instant, when this is the block is at extreme right position, this angle is 90 degree. As this is a tangent, so angle between crank and oscillating link is 90 degree. So at this instant, Vs2 is along this. So this is Vs2. And Vs3 by 4, that is the sliding velocity, which is also along link PQR. So, and Vs4, what is Vs4? Vs4 is perpendicular to PQR. Vs4 is perpendicular to PQR because link 4 has a pure rotation about point P. So velocity of link 4 at any point which will be perpendicular with PQR. So this vector equation can only be satisfied when these two are along PQR and this is perpendicular to PQR. So only can be satisfied when Vs2 is equal with Vs3 by 4 and Vs4 is equal to 0. So these two are equal and Vs4 is 0. As Vs4 is 0, if Vs4 is 0, then what is omega 4? That is, omega 4 is rotational speed of link number 4, that is Vs4 by PS4, this length PS4. So that is 0. So at this instant, when the slider is at extreme rightmost position, PQ, angular speed of PQ is 0. So what is velocity of point QR? So velocity at point QR is 0. So velocity point QR is 0, as this has no angular movement. So at point velocity 0. Now QR and RR is also on link number 5. So velocity at RR will also be 0 at this instant. So velocity of RR is also be 0. If you apply that, VQR and VRR will have same component along the link QRRR. So velocity, sliding velocity of RR, that is this block, is 0 when the block is at extreme right position. So extreme positions, extreme right and extreme left, the sliding velocity of the tool holder is 0. Now when maximum, when let me, so this you have understood that at the extreme position, that is 0. Now maximum when this, or let us calculate another intermediate position. This problem can be solved easily, but understanding is important. So let me describe it more clearly. Let us now draw another instant. When, say this is angle, so here angle between crank, so this is S2, S3, S4, this is P, this is O. So when the angle between crank and the oscillating link is theta, at this instant, what is Vs2? Vs2 is perpendicular to link 2. So this is Vs2, and Vs4 is perpendicular to link number 4. So if the angle between them is theta, then their angle between their perpendicular will also be theta. And Vs3 by 4, so this is Vs4, and Vs3 by 4 is along PQR. Sorry, if any position is denoted by Q, so that will be parallel to PQ, because this block is restricted to slide only along the oscillating link. So this is Vs3 by 4. So any another instant, that is the equation. So here Vs4, so Vs4 becomes what? Vs2 cos of theta. Vs2 is constant because omega is, as omega is constant, Vs2 is constant. All instant Vs2 has same velocity, and Vs4 is varying with Vs2 cos theta. Now here theta was 90 degree. So when theta was 90 degree, Vs4 becomes 0 because cos of 90 is 0. So when crank rotates from this position in counterclockwise, the angular rotation of oscillating link starts, and the value of omega 4 increases when theta decreases. When the crank rotates from in counterclockwise, it decreases from 90 degree to 0. So Vs4 is nothing but omega 4 into Ps4. So as theta decreases, when say from 90 to crank starts rotating, so theta decreases from 90, and here it becomes 0 degree, because at this instant when crank is at say OS here, then crank and the oscillating link coincides on each other, that is theta is 0 degree. So during the rotation from this to this position, from this extreme right to mid position, the theta decreases from 90 to 0 degree. So cos of 0 is what? Cos of 0 is 1. So when at this instant, when both crank and oscillating link are coincides on each other, then theta becomes 0 and Vs4 equal with Vs2. If Vs4 is maximum, that is the maximum value of Vs4. If Vs4 is maximum, the omega 4 will also be maximum. If omega 4 is maximum, then velocity of point Q will be maximum, because velocity of point Q maximum when this link has a maximum angular speed. And if Q have maximum speed, then sliding velocity of R will also be maximum. So maximum speed of this tool holder attains when it is at mid position of the stroke, that is the crank OS and PQ, say this is Q and this is link number 5, both coincides on each other. So this is the concept. So the maximum speed attains at the midpoint of the stroke, and two extreme points the velocity of the tool holder is 0. So here it attains maximum speed, and where at this instant this is Vs2, if this is S2, S is nothing but S2, S3, S4, this slider, this is the slider. So at this instant Vs2 is equal with Vs4 and Vs3 by 4 is 0. So at this instant when crank and oscillating link coincides on each other, that is theta is 0, this theta becomes 0, then Vs2 will be equal with Vs4 and Vs3 by 4 is 0, that is the sliding velocity of this slider at this instant is 0, but Vs4 is also maximum at this point. So now Vs4 is equal with when this block attains maximum speed, that is the instant. So at this instant what is the value of Vs4? Vs4 is equal with Vs2, and that is omega 2 into OS. What is omega 2? Is omega 2 is given, say omega 2 in the problem is 2 radian per second. So omega 2 is given, that is 2 radian per second. So 2 into OS we have determined, that is 250. So that is 500 millimeter per second. So if Vs4 is 500, then at this instant what is the value of omega 4? So let us find out omega 4 now. So omega 4 is Vs4 by